Hi everybody, my name is Crash Course and this is a two-dimensional Fallout inspired lockpicking minigame. So let me show you how this works. So you got your lock and you've got your lockpick, both represented by different sprites. The lockpick follows your mouse cursor around, and when you go to apply torque, if you're nowhere near the sweet spot, which is randomly generated at the start of the game, then your lockpick is going to jitter and your lockpick will take damage. However, when you start to find the sweet spot, it'll move either up to 30 degrees or, 60 degrees, or when you finally find it, 90 degrees, and you'll get a success message. If you fail and you break your lockpick by letting it take too much damage by trying to apply torque when you're not near the sweet spot, you get this failed message and it gives you an R to restart. Pressing R restarts the game, generates a new random sweet spot somewhere along the line, and once you find it, you're successful. So this is pretty reminiscent of how the Fallout games work, so lockpicking wise at least. So let's actually take a look at how this works behind the scenes. So let me preface this by saying it only took me 6 minutes to make those sprites, and then it took me about 4.5 hours to get all the logic behind how that works down pat in a way that I was happy with. So taking a look at the sprites here, because these are fairly important. Actually, let's look at the sprites. So this is the lock. The origin point is right here in the center, and this is important because when we're rotating it to make it give it the illusion of the lock turning towards being unlocked, we rotate it about this point. However, the lock pick sprite, the origin point is set to be at the end of the thing here, so that when we rotate it, it's the fat end of it follows your mouse cursor. So that's how that works. By setting the origin point, we control whereabouts the image is rotated around. So if we go to the actual objects themselves, let's take a look at the lock first, and we see we have a create event and a step event. So for those of you who are new to GameMaker Studio, the create event is ran when the object is first created and loaded into the game, whether it already exists in the room to start out with or whether it's created interim. And then the step object is run, or the step event, is run every single frame. So every single frame, it's performing all of the functions in here if the conditions are right. So we'll take a look at the create event first. So the very first thing we do is set the image scale. This is done because I wasn't really happy with the size of the sprites that I created, so I just kind of sized them up a little bit to make it a little bit more easy to see. We've got these three states here, and these are just Boolean variables, so these can either be true or false. So turning is equal to false when it's first created, success is equal to false, and fail is equal to false. And then we generate our sweet spot somewhere between the range of 5 and 175. So this random range function is supposed to give you a value between these two numbers here generated randomly. However, when I was trying to get this to work, it was generating the same exact value every single time I loaded the game. What I found is that you have to use this randomize function here beforehand, and this right here is what actually lets you get a different value every time you run it. So basically, we're going to move over to the step side of things now, and essentially before it even begins processing, actually let's first come down here to the create event for the lock pick before we get into what's happening every frame. So the image Y scale and the image X scale, which similarly to the lock pick, I wasn't happy with the size of the sprites, so I just blew them up a little bit. And then the X is set to, and the X and the Y value are both set to the X and the Y value of the lock object. So this is what binds these two objects together sprite-wise and lets you pivot around the middle of the lock. So this previous angle variable I had set, but I don't think I ended up using it. And then the lockpick health variable here is set to 100 initially, and that decreases if you apply torque when you're not near the sweet spot and the lock doesn't move. So if we come up here to the step variable, or the step event for the lock object, you can see that the lockpick angle is set to the image angle of the lockpick object. So that's important because we use this lockpick angle for a lot of our conditional checks down here. So the first thing that we're doing is checking for success and checking for failure before we even begin checking to see if the player is inputting anything or any other conditions. So basically, when the image angle of the lock, because you remember it was turning about that origin point, when the image angle gets to be 90, that's how you know that the player's won, because it's done a full 90-degree turn to the right. So we're checking to see if that is true first. And if that is true, then the success variable is set to true. Now, if the success variable is set to true, we've got a third object down here that kind of acts as the game running, the behind-the-scenes stuff here. So this is just a spriteless object that runs in the background. And essentially, when it's created, I've got a debug command in here, and I was looking for a way to get this to work, and I haven't done so yet, but I essentially wanted you to be able to press the R or the D key here to toggle the debug information from showing on the screen, in which the all these guys here would show up when you run the game. So actually we can set this to true, and I can show you kind of what that looks like, but I was doing this to test out the game. So you can see the different things that are shown up there. You can see the lockpick angle when you rotate it. You can see where the sweet spot is. So if you want to find it, then you can see the lock angle as the lock moves, and you can see your lockpick health. So if we are nowhere near it, you can see the lockpick going down, and then when it hits 0, you get the failed. So that was just something that was helpful to me in order to troubleshoot the different things that were going on with the application. And I highly recommend including some sort of debug function when you're first getting the framework down for the actual mechanics behind what you're seeing on the screen. So essentially, this draw command is what's important here, though. So it'll draw the debug information if debug is set to true, but it's then going to look to see if the success variable of the lock object is true, and if it is, it's going to draw green text that says success, and then press R to restart. And then this escape N character here, very similar to Python if you're familiar with that, essentially when it's reading this text, it's going to stop at this point and say, oh, they want to do a new line, so I can put another new line in here if I want to, and it's just going to keep adding lines. And that's very similar to down here. If the lock object has a failure variable that says true, then in red text it's going to say fail. So that's essentially how that works. So before it even begins checking to see what's going on with the player input and the rest of the processing here, it's going to check for success and check for failure. And then the resetting the lockpick position is just to make sure that the lockpick object is always set to be right in the origin point of the lock itself. And this is pretty important due to the jittering mechanic when you apply torque and the lock's not moving, to kind of give it that essence that you're putting pressure on it, but it's not doing anything, so you're causing damage to the lockpick. So when we check for torque, the very first thing we're going to see is these nested if statements. So if the mouse check button MB left, this is checking for whether or not the player is clicking the left mouse button, and then we're checking to see if the fail variable is equal to false. So if these two variables are true, or if these two conditions are true, then it's going to examine for the next set of conditions. So the first thing it's going to check is that lockpick angle, which is checked at the beginning of every frame, and then based on the image angle of the lockpick. So the sweet spot variable -10 and then the sweet spot variable +10 shows that essentially we're asking the game, is the angle of the lockpick within 20 degrees of the sweet spot? So it can be up to the sweet spot -10 or up to the sweet spot +10. And if that's the case and the image angle is less than 90, then every frame we're going to increment that upwards by 3. So if we are within 20 degrees of the sweet spot, increment upwards. Then the next thing it's going to check for, if this is not true, so if we're just outside of that, maybe we're within 40 degrees, as evidenced by giving it a threshold of -20 and +20, and the image angle is less than 60, so we can move that image angle up to 60 degrees before it's going to start jittering, and I'll show you how that works too. So if this condition is true, so we're within 40 degrees but not within 20 degrees, then it's going to let you get up to 60, so a 60-degree turn. And then essentially, if you're still holding down the mouse button, these conditions are true. You're still within the 40-degree threshold, but you've reached 60 degrees, then the lock is going to stop turning because you're almost there, but you're not there all the way. So essentially what's going to happen then is your lockpick's going to start taking damage because the lock is no longer turning. So this right here is setting that variable of lockpick health to be negative equal to 1. So that means every frame decrease this value by 1. So that's what we saw when we saw the lockpick health dropping. And then the object lockpick.x is set to a random range between -2 and 2, and that's what gives it that jittering effect. So the x value, which represents where this sprite is drawn on the x-axis, is set to a random range between -2 and 2 from where it is now. So essentially every frame it's jittering left and right to show you that you're applying pressure on it and it's not doing anything, and that you're causing it to be damaged. And that's why this this reset lockpick function is here, so that it's even if it jitters a little bit at the start of the frame, it's going to go back to where it was before, so it doesn't get out of sync even if you hold it down. And then the next set here is basically just another threshold, almost or actually identical to the above, except it's given you a lenience of 60 degrees. So if you're within 60 degrees, as evidenced by +30 and -30, then it'll let you turn the lock up to 30 degrees, at which point it's going to start causing damage to your lockpick. And then if you're pressing down the mouse and none of these three conditions are true, so you're not within 20 degrees, 30 degrees, or 20 degrees, 40 degrees, or 60 degrees of the sweet spot, then your lockpick is just going to jitter and take damage. So, and then very similarly to the Fallout games, when you're not applying torque, the lock is constantly decreasing back to its starting point. So if the image angle is not equal to 0, which it's not if it's being turned, and you're not clicking the mouse button, then it's going to slowly, well, not slowly, but at a rate of -3 degrees per frame, return back to where it was before. So that's what's going on behind the scenes there. And yeah, so that's basically how that works. So and then the step object or step event for the lockpick object is essentially if the point direction of the mouse is less than 180. So this is what keeps it, and let me show you this too, because this is important and it took me a little while to figure out. When we get to this point right about here, it stops following your mouse so that you can't just spin this thing all the way around and work similarly on this side. That is because it's first checking to see if the position of the mouse is less than a 100-degree angle. So as long as you're not going below that lockpick, you're essentially not going above 180 degrees. So if you are going beyond the bounds of that 80-degree angle where the lockpick is allowed to go, then it's not going to follow your mouse, is essentially what's happening. So because of this line of code right here, you can't go out of bounds with that 180-degree playing space that we give the player. So and then it's going to check if the lock is turning, then it's also not going to follow your mouse. So you can't turn the mouse while it's or turn the lock while you're, you can't have the lockpick follow your mouse when you're applying torque to it. So it's just one of those little minor things that I don't want to get glossed over here. And then, so basically, if these two conditions are true, then it's going to follow your mouse. And then this previous angle variable here was originally going to be used for some sort of functionality that I don't remember at this point, but it was essentially kind of taking a snapshot of the current image angle of the lockpick and storing it in this variable here so that at the next frame we could do something with that information, but at this point that's not being used. So at this point, that's pretty much how it works. You can see I've got the screwdriver sprite here, which is not being used currently. In the Fallout games, the player uses a screwdriver to apply the torque based on where the lockpick position is. It pushes in against the bottom of the lock to assist with the lockpicking. I was originally going to try to program that in to be animated the way that it works in the Fallout game, but I haven't attempted that yet. But mechanically it is working, and this would just be kind of a cosmetic addition to what's going on here. So at this point, that's essentially how it works. Now, polishing this going forward and making it better, essentially, if you wanted to fit this somewhere in your game, all you would need is an event that calls the creation of the lockpick and lock objects, and then you would need it to return some sort of variable if the player was successful. So essentially, you'd come down, or you'd come up to the lock object, and if the success was reached, then you would essentially just destroy this object and then the lockpick object, and then return or set another variable somewhere, letting the player know that the container that was locked, or whatever it was they were trying to access, be it a door, a container, a chest, or something along those lines, is now unlocked. So you'd essentially have another variable which acts as a switch that is changed by the success of this event, and then the player can then access what's in that inventory or access the door. So that's how you'd implement it into a game. Now, the sprites themselves do need some work. Like I said, I whipped these together in about 6 minutes because I'm way more interested in learning how to program these mechanics. But the very last thing that I want to touch on, if you've made it this far into this video, that shows me that you're interested in this and the rationale behind everything. I can't say this enough. I erased and started over so many times because I'd run into the issue, to various different issues with trying to get this logic to work, and I couldn't understand what was going on. And then when I finally found a thread somewhere in the forums or in the documentation of what's going on and what needs to be fixed, it kind of rang true that maybe I'm not approaching this in the right way. So take one more step back, look at how you're writing it, and then if you find something that it just makes sense as to why would you not do it that way, as grueling and tedious as it is, start over. You will learn so much by doing that. So I did that, must have been 5 or 6 times with all this logic here that I ended up using. And even though this looks like something very simple, this was made on my second day using the GameMaker Studio 2 application, and so admittedly, to people that are more familiar with programming and more familiar to this application or game design in general, this would have been almost a no-brainer. But for those of you that are new, understand that this stuff is going to take some time to learn. Don't be intimidated by the fact that wherever you go, it's going to seem like everybody else has it figured out, because chances are they do, but it took them an incredible amount of time and commitment to get there. And let me tell you, there's nothing that feels better than it being 11:30 at night and having finally completed something into something that's workable. And it kind of makes me less bummed out knowing that somebody's going to come along in the comments and say, hey, why'd you do all this here? You know, you can shorten this up to one line of code and it'll perform better and it'll look better. It's less apprehensive to bugs. So the last thing that I want to say is that I really, really welcome that feedback. My hopes are that somebody who's brand new to this stumbles on this, or even a seasoned designer stumbles upon this just looking for another way to tackle a locked object in their game, sees this as some sort of inspiration and then improves on it. So down in the comments, if you have any constructive criticism to add to this, or even if you need to tell me this is really bad, at least offer some sort of retort showing what you do differently or do better so that people can learn from this too. So again, I thank you very much for watching. If you've made it this far, stick with it and let me know if there's anything about this that you think could be improved, or if there's another mechanic of Fallout that you would like me to tackle for a 2D iteration. The goal here is not to make and then release a 2-dimensional Fallout game. The goal is for me to just practice the different nuances of game design and kind of get my bearings with programming in this application by taking some of the elements that are found in the more modern Fallout games, giving them a 2-dimensional iteration, and learning what I can along the way and then sharing it with you. So this is educational purposes only. No copyright infringement is intended. This game will never be released, no matter what state it's in. Anyways, hopefully you were able to learn something. This has been Crash Course. Thank you very much for watching.